This is a video on how to use the sum of the angles cosine formula, or cosine of the sum of the angles. Now the formula, of course, is cosine A, cosine B minus sine A, sine B. Another way of looking at it is cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. That way, whether these are A and B or alpha and beta or whatever angle letters we want to use here, the idea comes across that you take cosine of the first, cosine of the second, sine of the first, sine of the second. And with the cosine formula, if it's plus in here, it's guaranteed to be minus out there. So here I have two angles, 45 and 60. If you add it together, you get 105, and it's really hard to find the cosine of 105. So this is one of the nice things about the cosine of the sum angle formula. We can separate it out so we can work individually with 45 and 60, which we should know all about. So this is going to become, that's too thick, cosine of the first angle, 45 degrees, times cosine of the second angle, 60 degrees, minus sine of the first angle, 45 degrees, times sine of the second angle, which is 60 degrees. Alright, so if you don't know what your special triangles are, draw them over here real quickly. 30, 60, 90. I'll draw it like this. So here's 30, 60, 90. These you should memorize. This side is 1, opposite the 90, which is the biggest angle. Biggest side is 2. The middle angle and the middle side is square root of 3. And then the other one is the 45, 45, 90. Try to draw it decently here. Ugh, that's ugly. So if this is 45 degrees and this is 45 degrees, oops, this is 1, 1, and then the hypotenuse being the longest side is square root of 2. Alright, so cosine of 45, you would be looking at this angle, and cosine is adjacent over hypotenuse, so that would be 1 over square root of 2, also known as square root of 2 over 2. Don't write cosine of square root of 2 over 2. We're evaluating cosine of 45, and it's equal to square root of 2 over 2. Alright, cosine of 60, well that would be this picture. Cosine of this angle up here is adjacent over hypotenuse. Some old hippie caught another hippie. So 1 is adjacent, 2 is hypotenuse, so you get a half here. Minus sine of 45, if we look at 45 here, sine is some old hippie, so opposite over hypotenuse. And again, if we rationalize the denominator, we get square root of 2 over 2. And then sine of 60, we go back up to 60 up here. Sine is opposite over hypotenuse, so opposite is square root of 3, hypotenuse is 2. So you get square root of 3 over 2. Alright, and then all we need to do is simplify this. So if we multiply these fractions together, remember, straight across, this becomes the square root of 2 over 4. Over here, you're going to get square root of 2 times square root of 3, better known as the square root of 6. And then, of course, 2 times 2, 4. They have a common denominator, so we can write this as square root of 2 minus square root of 6 all over 4. And this would be the cosine of 105 degrees. Alright, we can do the same thing with the difference of the sine. There's also a sum of the sine formula, and it's really easy to remember. When we're dealing with sum or difference of sine, the pattern on the other side is either sine, cosine, sine, cosine, but then the angles have to flip their order, or some people like sine, cosine, cosine, sine, and keep the angles in the same order. I'm more particular to the first one, because I like keeping the functions in order, and I just remember to switch the angles. One thing to check yourself on is if you're doing sine of one angle over here, the sine of this angle has to be different, unless A and B are exactly the same, which would be kind of boring. Alright, so I'm going to use the top one for this. This is 120 minus 45, better known as 75 degrees. So here we're trying to find the sine of 75 degrees. So I'm going to use the top one up here. So sine of A, cosine of B, Sine of the second one, cosine of the first one. So sine of the first angle, 120 degrees. Cosine of the second angle, 45 degrees. And one thing with the sine, which is different than cosine, if it's minus on the inside, it's minus on the outside also. Cosine is completely opposite. If it was minus on the inside, this one would be plus. But in this case, minus. And then sine of the second one, 45 degrees, and cosine of the first one, 120 degrees. All right, now these two should be simple. Cosine of 45 and sine of 45, they're both square root of 2 over 2. So the 120 we're going to have to worry about. So the first thing we need to know is what quadrant is 120 in? Well, this gives you 90, the first quadrant. The second quadrant will bring you up to 180, so someplace in the second quadrant. So I would draw my special triangle in the second quadrant. Okay. So if this is 120 degrees, the reference angle, choose a different color here, would be what's left over to get you to 180. So that would be 60 degrees. So if that's 60 degrees, this one up here is 30 degrees. Obviously the picture's not that great. And opposite the smaller side is the smallest, opposite the smallest angle is the smallest side, which would make it 1. Because it's going in the negative direction, I like giving it a negative. Then I don't have to worry about all students take calculus. Then opposite 60 would be square root of 3. Opposite the 90 degrees, or the hypotenuse, would be 2. All right, so now we can find the sine of 120 and the cosine of 120. All right, so the sine of 120, this angle, would be from the reference angle, opposite over hypotenuse. So this would be square root of 3 over 2. Oops. And then cosine of 45, square root of 2 over 2, minus sine of 45, square root of 2 over 2. And then cosine of 120 would be reference angle of 60, adjacent over hypotenuse, so it would be negative 1 over 2. And then we just have to simplify. Here I'm going to skip to the common denominator. We're going to get a 4 here and a 4 there. So I'll just draw the long line and put a 4 on the bottom. So square root of 3 times square root of 2 is square root of 6, minus square root of 2, negative square root of 2 times negative 1 would be a positive square root of 2. So the sine of 75 degrees is equal to the square root of 6 plus the square root of 2 all over 4. All right, here's another possibility with a sum or difference of the angles of cosine or sine. Here we're given this long string of sine and cosine, and there is no way of directly finding cosine of 3 pi over 8 or the cosine of pi over 24. But because it's in this setup, we can match it with a formula for the cosine of the difference of the angles. Now remember, with cosine, if it's minus on the inside, it's plus on the outside. And because it's going cosine, cosine, sine, sine, I recognize that as the cosine pattern. So what I can do here is rewrite this in terms of the formula, just going backwards. This would be your first angle, A. This would be your second angle, B. And on the other side, this would become cosine of the first angle, 3 pi over 8, minus the second angle, which is pi over 24. So all this mess on the right-hand side shrinks down into this little piece. Of course, now we could simplify this. It becomes cosine. We're going to need a common denominator here. In this case, it would be 24. And if the denominator is 24, then we're multiplying this 8 by 3. So if we multiply the 8 by 3, I'll put it in there. We also have to multiply the top by 3. And 3 times 3 pi would give us 9 pi. So here we'd have 9 pi minus the pi that already had the 24 in the bottom. And then this would simplify to be cosine of 9 pi minus pi is 8 pi over 24. Oops. And then that simplifies to be the cosine of pi over 3. So we can find the cosine of pi over 3 really quickly. It's a reference triangle. Here's 30, 60. This is 1, 2, square root of 3. Smallest side, smallest angle, biggest side, opposite. All right, so pi over 3 is 60 degrees. So the cosine of 60 degrees would be adjacent over hypotenuse. So this equals 1/2. We can use that same technique to figure out what the sine of 5 pi over 12 is. Again, finding the sine of this weird angle is not going to work because we only know how to work with the pi over 2 multiples, the pi over 4 multiples, the pi over 3, and the pi over 6 multiples. So 5 pi over 12 is none of those. So one trick we can play is using this number, what are things that add together to give you 5 pi over 12? Or subtract, it really doesn't matter. So I know that I'm going to split this into two angles whose denominator is 12. And they're both going to have a pi in the top. So I just want to play with numbers that go in this position that add up to 5, but also reduce with the 12 into something like pi over 2, pi over 3, pi over 4, or pi over 6. So the numbers I can play with are 6, which would give you the pi over 2, the 4, which would give you pi over 3, the 3, which would give you pi over 4, and then a 2, which would give you pi over 6. So these are the numbers I need to figure out here. So 5 has 4 and 1 add up to it, but 1's not going to work because it doesn't reduce with 12. It also works with 3 and 2. So if I put in 3 and 2, those are two numbers that divide evenly into 12, and hopefully it gives us a denominator of the 4, the 6, the 2, or the 3. All right, so 3 pi over 12 is also known as pi over 4. The 2 pi over 12 is known as pi over 6. So 5 pi over 12 is the sum of two angles I know a lot about, pi over 4 and pi over 6. So I can rewrite this as the sine of pi over 4 plus pi over 6, and then just need to use the sum of the sine formula, or the sine of the sum of the angles. Now the sine pattern is sine cosine for both pieces, and then it's first angle and second angle. With sine, because it's plus on the inside, it stays plus on the outside. And then I usually just do the same thing, sine cosine, but I have to take the angles and switch them. So this is going to be pi over 6, and this one's going to be pi over 4. All right, special triangles. If this is 30, this is 1, 2, square root of 3. Oh, that's doing really bad with the 45-degree angles. 1, 1, square root of 2. Let's put these right angles in here. There we go. All right, so sine of pi over 4 is 45 degrees, and sine is opposite over hypotenuse, so that would be 1 over square root of 2, also known as square root of 2 over 2. Cosine of pi over 6, which is 30 degrees, cosine is adjacent over hypotenuse, so that would be square root of 3 over 2. Sine of pi over 6, back to the 30 degrees. Sine is opposite over hypotenuse, so that would be a half. And then cosine of pi over 4 is that square root of 2 over 2. So this would equal the square root of 6 plus the square root of 2 over 4. And this would be the sine of 5 pi over 12. So this sum and difference formula angles are, kind of interesting, but we're going to use them a little bit more in the next section to create formulas that are actually much more powerful.